For this lesson, we're going to look at the slope-intercept form of an equation of a line. And we'll start with just taking these three lines that are shown on the graph and matching it to the equations that are listed there. And when you're matching them, maybe think about looking for the y-intercepts of each equation. So as a reminder, the y-intercept is where your graph or your line intersects the y-axis. It's when the x value of your function is 0. So for the y-intercept, we'll just set our x values to 0. So for a, you'd have 2 times 0, which is 0, plus 3. So your y-intercept is 3. Or the y-intercept for b would be -0, or just 0 plus 4, which is 4. And the y-intercept of c equals 0 minus 2, which is just a -2. So you can kind of see that if you list your equations this way, 2x plus 3, -x plus 4, half x minus 2, that this number on the end, those show your y-intercepts. Okay, so let's match them on the graph. Graph 1 then, you can see has a y-intercept of 3. So graph 1 is equation A. Line 2 in green has a y-intercept of -2. So we know that that would be line C. And line 3 has an intercept or a y-intercept of 4. So we know that is line B. Okay, so we match the lines using y-intercepts. Now let's take a look at the slopes of each line as compared to maybe what you see in the equation. If we look at the slope of line 1, we see, let's go from this point to this point. We went up 2 and across 1. So the slope of line 1 there equals 2. For line 2, if we go from this point, say to this point, we can see that our slope is 1, 2 up and 1, 2, 3, 4 across. So the slope is 2 over 4, or 1/2 as a reduced fraction, 1 over 2. And then finally line B, we can take this point again and go down to this point. And we're going down 1, 2, and we're going across 2. So the slope is a -2 over 2, which is the same as a -1. And notice that those slopes match part of the equation, don't they? They match the number next to the x. So that number next to the x, or the coefficient of x, is your slope. So if you write an equation of a line in this way, where you have some number times x plus or minus some other number, we call that the slope-intercept equation of a line, because that type of equation expresses immediately what your slope is and what your y-intercept is. So coefficient of x is the slope when you write an equation this way. So let's sum this up. This in the red box is the slope-intercept equation of a line. So a linear function, which means the equation of a straight line on a graph, can be written in this slope-intercept form. Why do we call it slope-intercept form? Because that spells out for you immediately what the slope is, being the number next to the x, or the coefficient of the x, and it says what the y-intercept is right away. So slope-intercept form is y equals mx plus b. M is your slope, b is your y-intercept. So let's use this slope-intercept equation of a line to graph a line. Here we have a function y equals 3x minus 2. So we know from this that your y-intercept equals -2, and your slope equals 3. That's what the equation tells you. So what you'd want to do is start with your y-intercept. This y-intercept of -2 means your line passes through that point. And find another point or two using the slope. Our slope is 3 or 3 over 1. So we go up 3 and across 1 to find our next point. We can go up 3 and across 1 to find another point. We can even go down 3 and to the left 1 to find another point. But you need at least 2 points to make a straight line. And you can draw your line through those points. And we have just graphed a line using the slope-intercept form of an equation. What if we were shown some graphs and we want to figure out what the equation of those graphs are, what the equation of the lines are? Well, what you'd want to do is figure out what the slope is, figure out what the y-intercept is, and fill those numbers in the y equals mx plus b form. So let's take a look at line A there. For line A, it intersects the y-axis here. So that is 3, 4, 5. It intersects the y-axis at 5. That's your y-intercept. So for A, your y-intercept, which is the B part of the equation, let me write it over here, is 5. Well, what about the M? What about the slope? Let's choose a point on the graph that we can calculate a slope with. That's a nice point. And your slope, it seems, if you're going from the point on the left to the point on the right, you're going across 2, or your run is 2, and your rise is 1, 2, 3, 4. 4 over 2, which reduces to 2. So that is your slope. So slope is 2, y-intercept is 5, therefore the equation is just 2x plus 5. For line B, here's your y-intercept, y equals 1. So in this case, for line B, your y-intercept is 1. And your slope, let's choose another point on the graph right here, intersects is a good point to use. To get from the left point to the right point, we go down 1, 2. So the vertical change or the rise is -2. And then across, or the run, is 1, 2, 3. So your slope is -2 over 3. Putting it into the y equals mx plus b format, y then would be -2 over 3x plus 1. Okay, for 4 and 5, we're going to use the information given to us in order to write an equation of a new line. So number 4 says, we have a new line that is parallel to some original line that has this equation, and the new line has the same y-intercept as the other equation. What's the equation of the new line? Well, what's the slope of the new line? If the new line is parallel to the old one, then the new line has the same slope, -1 over 4. If the new line has the same y-intercept as the second line there, given to us, then its y-intercept must be 2. So the equation of the new line must be y equals the slope of -1 over 4, x, plus the y-intercept of 2. How about number 5? Number 5 says the new line is going to be perpendicular to -5 over 9x plus 6. So we'll have to do something with that slope. And it passes through the origin. Remember, the origin is the point 0, 0. So with the origin, your x-intercept and your y-intercept are both 0. So what should your slope be? The slope of the perpendicular line needs to be the negative reciprocal. So instead of -5 over 9, a positive 9 over 5. Whereas the y-intercept is 0. So your equation then is y equals 9 over 5 x plus 0, which you can just write as 9 over 5 times x. Last example, we're asked for the equations of horizontal and vertical lines. So determine the equations of the horizontal and vertical lines that pass through the point 6, -3. So 6 along the x-axis, -3 along the y-axis that pass through that point there. Well, a horizontal line is straight across. And with the horizontal line, if you were to look at the slope-intercept form, so if I'm looking at the horizontal line here, slope-intercept form says it's y equals the slope times x plus the y-intercept. But the slope is 0, right? A horizontal line, the slope is 0, there is no rise. So this is like 0 times x, whereas your y-intercept is -3. So your horizontal line, the equation is going to be y equals -3, because 0 times x is just 0. As far as the vertical line that passes through this point passes at x equals 6, and the slope is undefined, so we can't write that mx part. There is no y-intercept, so vertical lines don't have an equation that says y equals. But you can see that the vertical line, it always has a value of x equals 6, right? The x value is always 6. So you can say for the vertical line, the equation is just x equals 6. So the y equals mx plus b equation, we call that slope-intercept form. And there's going to be other equations of lines, or forms of equations of lines, that we're going to learn as well.